Hi and welcome to this video on unknown coefficients. So in this video we will look at finding unknown coefficients given an identity, and we will explain a little bit more about what an identity is. So if you've not already revised algebraic long division, I think that would be a very good idea to do. There's a little bit of simultaneous equations, but it is quite basic. So the video today will be covering basic unknown coefficient examples using simultaneous equations, but like I said, very basic simultaneous equations with two unknowns to find the unknown coefficients. And then finally we're going to look at multiple methods to solve a higher level style question. And it's going to be presented as a function and given factors. So it may not be immediately obvious that it's an unknown coefficient question. So we'll look at three different methods to solve that. So when we're looking at unknown coefficients, we're focusing on something called identities. So x squared equals 16 is an example of an equation. So an equation is something that contains an equals. In this equation, there are only two values of x, where x squared will be equal to 16, and that is x equals 4 and x equals minus 4. An equation that is true for every value of the variable is called an identity. For example, x minus 2 all to a squared is equal to x squared minus 4x plus 4. That is an example of an identity. This identity will be true for all values of x where they are an element of the real numbers, and this is because the left hand side is always equal to the right hand side. So if you look at that example there, you'll see that that left hand side is the same as the right hand side. So you could ask, what value is it if I have something that looks like this? Well, we're going to be able to use the fact that we have an identity and we know that the left hand side is equal to the right hand side to solve for unknown coefficients. So example 1, we're told that if 10 times ax plus b is equal to 50x plus 30 is true for all values of x, find the value of a and the value of b. So what we've been given is an identity. How we identify that we have an identity is because we've been told that it's true for all values of x. If we haven't been told that, then we couldn't use this method, and this is one of the key things in a question that will indicate to you that we are working with an unknown coefficient question. So let's start with what we have. 10 times ax plus b equals 50x plus 30. Multiplying out the left hand side, I get 10ax plus 10b equals to 50x plus 30. Now, we know that the left hand side is equal to the right hand side. So what you may be able to spot now at this point is how we could get the values of a and b. If you can't straight off see it, I would advise you to break it down like this. Even if you can see it, I would still advise you to write this out to show your workings. So let's work first with the x terms. This is anything that contains an x. Then we'll work with the constants or the non-x terms. So for the x terms, I have on the left hand side 10ax, and that should be equal to, on the right hand side, 50x. At this point there's an x on both sides, so I can divide across by x, and at this point I'm going to divide across by 10. So I get the value of a is equal to 5. Working with the constants or the non-x terms, we get 10b is equal to 30. Dividing both sides by 10 gives us b is equal to 30 over 10, b is equal to 3. So using that idea of the left hand side is equal to the right hand side to help us find those unknown coefficients a and b. Let's look at a slightly harder or more challenging example now. What we have in this case is a little bit more work to do on that left hand side to multiply out that bracket before we can start equating the terms. So I have ax minus 2 times x minus b is equal to 2x squared plus 6x minus 8. So I'm going to leave the right hand side as it is for a minute because there's nothing I can do with it, and let's work just with the left hand side. So splitting out our brackets to multiply, we get ax times x minus b minus 2 times x minus b. I get ax squared minus abx minus 2x minus y minus gives us a plus 2b. At this point, I'm going to fill back in my right hand side, and then we'll start equating. Just a few things to talk about before we get into equating the terms. When I multiplied, I'll come back over here. When I multiplied ax by minus b, some people would write minus bax. It's good practice to write your letters in alphabetical order when we work with them. If you always write your letters in alphabetical order, then you won't be left with a case of not being able to see terms that could possibly be added together. So let's break this down. In this example, we have x squared terms. We also have x terms. And we have constants, or if you prefer, non-x terms. Why I'd advise you to use non-x terms instead of constants, but still keeping that word in your head, is as we're working with a lot of different letters, sometimes constants, it can be hard for students to identify that something with the letter is actually a constant. So if you say a non-x term, you're looking for any term that doesn't contain an x. It will lead to a few less issues. So x squared terms, I have ax squared is equal to 2x squared. I have an x squared on both sides, so I'm going to divide across by x squared, and I'm left with a equals 2. With my x terms, I have 2, so I have minus abx and a minus 2x, and that is equal to 6x. They all have an x, so I'm going to divide across by x. So I need to do a little bit of work here. I have minus ab minus 2 equals 6. I'm going to add a 2 to both sides, which will give me 6 plus 2. So I have minus ab equals 8. Now, from the first piece, I know that a was 2. So what I get is minus 2b is equal to 8. Therefore, dividing both sides by minus 2, I get b is equal to minus 4. I can, at this point, stop. I have got my value of a and I've got my value of b, but let's work out the non-x terms just so you can double check that we're correct. So non-x terms, 2b is equal to minus 8. Dividing both sides by 2, get minus 8 divided by 2, b is equal to minus 4, which is exactly what we got with our x terms. Now let's look at an example where we'll have to use simultaneous equations to solve this in the end. This left-hand side of the identity is a little bit more complicated than what we've seen before. There are 4 brackets. There's 2 sets of multiplication that needs to happen to clean up the left-hand side before we can do any equating. A question like this is a great way for somebody to examine how your basic algebra skills are, so your multiplication, adding like terms, etc., as well as then testing how you work with unknown coefficients. Because of the number of terms in each of these, I'm actually going to go straight to the question and label my left hand side and right hand side. I'm just going to work with my left hand side to save me writing that right hand side out multiple times while I work through it. P times x plus 2 times x plus 1 minus q x minus 3 x minus 1. When you're multiplying 3 terms, it's important to remember that order does not matter. So if you decide to multiply the first 2 terms and then your answer by the third, or if you decide to multiply the second and third term and multiply your answer by the first, that's absolutely fine. So what I'm going to work with here, I'm going to multiply in the p first. So I get px plus 2p times x plus 1. I'm going to do the exact same thing here, but if I multiply in that q, I have two options. I can leave my minus outside and simply multiply in by a q, or I can multiply in by a minus q and make sure I put a plus here. I'm going to leave the minus outside, and I have qx minus 3q times x minus 1. Multiplying out these brackets, we split the first bracket, so px x plus 1 plus 2p times x plus 1 minus, split this first bracket, qx times x minus 1 minus 3q times x minus 1. Multiplying out, we get px squared plus px plus 2px plus 2p minus qx squared minus qx minus 3qx plus 3q. Now dealing with the minus, I'm going to have to effectively multiply that second bracket by a minus 1 or change the signs. Plus px plus 2px plus 2p. I then get a minus qx squared, a plus qx, watch your signs, a minus by a minus, a plus 3qx, and a minus 3q. So because of all our unknown coefficients, that's going to be very difficult to group together. We're not going to be able to simplify it down. So we're going to go straight to equating terms. So because I have so many terms and I don't want to lose any, what I'm going to do is I'm going to use different colors and shapes to help identify my terms. So there are my two x squared terms. I have an x term, an x term, an x term, and an x term. I have a constant and a constant. That should all, according to the question, be equal to 5x squared plus x plus 12, which is my right hand side from the question. Again, doing the same idea, there's an x squared term, there's an x term, and there's my constant or my non-x term. I'm now going to equate each of those. So just to give a bit more space, I've just moved that last line up to the top and got rid of all our previous work. So now let's start the equating. So let's start with our x squared terms. Then we'll work with our x terms. There's quite a number of those. And then we'll work with our non-x terms. Okay, so our x squared terms, we have px squared on the left hand side minus qx squared on the left hand side is equal to 5x squared on the right hand side. We're going to divide across by an x squared, and that gives us p minus q is equal to 5. Notice that we don't get a valid or a number answer for either p or q. Instead, we have a little equation, little linear equation with p and q. We're going to need this in a second, and I'm going to label this equation 1. Now looking at our x terms, we have px plus 2px plus qx plus 3qx, and that should all equal x. So I'm just going to move over our non-x terms to give ourselves some space. So it might be easier to see at this point the cleanup, or you could have done it at the previous step. There would have been no issue. So we have a px and a 2px. We have a 3px. We also have a qx, a plus 3qx, which gives us plus 4qx, and that is all equal to an x, or if you would prefer, we can write that as 1x. Again, I'm going to divide everything across by an x, and I get 3p plus 4q equals 1. And that becomes our equation 2. Now, we can go straight into simultaneous equations there and work with them. But before we do that, let's take a quick look at our non-x terms. On the left hand side we have 2p minus 3q equals, and on the right hand side 12. So we now have three little linear equations in p and q, which we can use now in order to solve for p and q. We're going to use simultaneous equations, and we're going to use the elimination method. We have three equations here, but we only need two, so we can choose whichever two we think will be easiest to work with. I'm going to work with equation 1 and equation 2 because equation 1 is the simplest. It has a coefficient of 1 for p and a coefficient of minus 1 for q, and it'll be easy to work with. I'm then going to work with equation 2. So let's work with equation 1 and equation 2. Equation 1 is p minus q equals 5. Equation 2 is 3p plus 4q, and that equals 1. I want to use the elimination method, so I'm going to get the q's to eliminate. To do that, I'm going to multiply equation 1 by 4. That gives me 4p minus 4q equals 20. Don't forget to multiply out that constant at the end. 3p plus 4q equals 1, and you can see now the q's will eliminate or give us 0. 7p is equal to 21. Dividing both sides by 7, and I get 21 divided by 7, or p is equal to 3. So that is one of our values. Going back to equation 1 then, you can work with any equation to get q. I'm going to use 1 because it's the simplest. P minus q equals 5. I now know p is 3, so 3 minus q is equal to 5. Subtracting a 3 from both sides, I get 5 minus 3. Minus q is equal to 2, therefore q, dividing across by minus 1 or changing the signs, whichever way you want to think about it, q gives me minus 2. And there's our answer. So you can see how the unknown coefficients, again in a question like this, it's testing how well you can multiply out brackets, and it's also testing simultaneous equations, as well as the unknown coefficient piece, which is equating the x squared terms with the x squared terms, and so on. If you had used equation 1 and 3 or 2 and 3, you would have still got the same answer for this, but there is no need to go back. If you do want to double check, you can go back to equation 3 and ensure that when you sub in p is equal to 3 and q is equal to minus 2, that works, and that's a way for you to double check your work. So now we're going to look at a function and factor style question. So this is very much what we generally see with regards to higher level style question. So I'm going to show you three different methods to doing this question. I'm going to do the missing factor method, which is nice but has a few tricks to it. Then I'm going to do a long division method, which is probably the one I would tell you to avoid unless you're very, very comfortable with long division. And the third method, which I think is possibly the easiest, but tends to be the one that maybe students don't recognize straight away, is using the idea of roots and getting simultaneous equations. So, first one, missing factor. So, I've been given two factors for a function. So, let f of x equals 2x to the power of 3 plus ax squared minus 17x plus b, where a and b are constants. Given that x minus 1 and x plus 4 are factors of f of x, find the value of a and the value of b. So I've been given two factors and my function is a cubic. Now, hopefully at this point everyone knows that a cubic does require three factors. So I have x minus 1 multiplying by x plus 4 multiplying by some other missing factor, and when I multiply them out I get 2x cubed plus ax squared minus 17x plus b. Now, what we generally let the third factor be is x plus k, because it's nice and simple. Generally k isn't in the question. If k is in the question, you have to use another letter. However, if I just stick in here x plus k, something is not right. Hopefully alarm bells will ring. And if you look at my three brackets, I multiply an x by an x by an x, and I get a 2x cubed. So no, it's not enough to just put x plus k. I also need this too. So in the case of using this method, watch out for the coefficient in front of that x cubed, because oftentimes when students try this method, they just do x plus k and then nothing works out because nothing is balancing up. So just watch out if a coefficient is required. Okay. So now all we're going to do is multiply out our three brackets and equate the terms as we have been doing before. So I'm going to multiply two at a time. So I'm going to leave that one as is, and I'm going to multiply these together. So you can work it out the long way. I'm just going to quickly jot it down. 8x kx. Okay. And that equals 2x cubed plus ax squared minus 17x plus b. So we need to multiply this out. So you get 2x cubed plus 8x squared plus 4kx plus kx squared minus 2x squared minus 8x minus 4k minus kx. Okay, and that still all equals 2x cubed plus ax squared minus 17x plus b. Okay, so we have a lot going on here. Just taking a quick look, can anything be cleaned up? So I can see we have an x squared here, but kx squared, but I have an x squared here that I could clean up. Other than that, unfortunately, everything will have to stay. So you have 2x cubed. I have 8x squared minus 2x squared, so I get plus 6x squared. I'm just going to put the plus kx squared up beside that here. I then have a plus 4kx. Oh, and I have a minus kx. Actually, I'm going to rub this out. Apologies. I didn't spot that. So I have a plus 4kx and a minus kx. That does clean it up a little bit for me. So I get a plus 3kx and minus 8x minus 4k. So now everything's nice, it's in order, and it's simple as possible. So we're going to equate our terms. So x cubed terms. Now, if you had forgotten to put that 2 into our extra factor, this is where you'd see the problem. You'd have x cubed equals 2x cubed, and that's not true. Now, there it's not very helpful at all, but at least we know we were correct. So now let's look at our x squared terms. So our x squared terms, we have 6x squared plus kx squared, and that equals, clean all this up, equals ax squared. Okay, and the x squareds can be ignored. I then have my x terms. So my x terms are 3kx minus 8x, and that all equals to minus 17x. So my x's cancel, and actually straight away here I can work out what k is. So I will work that through. The reason I didn't work through the x squared is because I had a k and an a. So I bring my 8 across, so I have minus 17 plus 8 equals minus 9, therefore k equals minus 3. So I can actually go back here and say 6 minus 3 equals a, so a equals 3. So there's one of my answers straight away. And now I just need to work out my non-x terms. So they're my constants, but I think calling them your non-x terms, students tend to get on a little bit better with them because they remember, well, actually it's not about the letters, it's about the ones that don't have the x. So minus 4k equals b. I already know that that's minus 3. And I get b equals 12. Great, so I found my value for a and my value of b using the missing factor method. So letting 2x plus k being the missing factor, working it through, a lot of multiplication, but very much the traditional style of the unknown coefficients question.
So let's look at method 2, which is long division. Now, in order to do long division efficiently, I would say take your two factors and create a bigger factor by multiplying them together. So we're going to take x minus 1 and x plus 4, and we're going to multiply them together. So they're both small factors, and by multiplying them together, we get a bigger factor that also divides into f of x. What that means is the long division is going to be a little bit shorter and a little bit easier to work with. Now, you can divide in an x minus 1 or an x plus 4, but that will make the question even more challenging. So multiplying this out, we get x squared plus 3x minus 4. So now I'm going to divide this in, x squared plus 3x minus 4, and divide that into 2x cubed plus ax squared minus 17x plus b. Now, long division when there's unknown coefficients can be really tricky, really challenging. So it can be helpful to have a little rough work column here that we can use. So x squared divides into 2x cubed 2x times. So just for long division, we divide, multiply, subtract, bring it down and start again. So 2x by x squared gives me the 2x cubed. These two numbers should always be the same because we want them to effectively subtract to give us a 0. We then multiply 2x by the plus 3x, which gives us plus 6x squared, and then 2x by minus 4x, that's minus 8x. So we've divided, so only ever divide the first term by the first term. So the division was 2x cubed divided by x squared, which gave us that 2x. The multiplication is then 2x multiplied by each of the three terms. We then have subtract. Now, when we're subtracting, that effectively is a change of sign. Because if I subtract a negative, it becomes a positive. So what should happen is those first two terms should cancel each other out. We should go to 0. And we're left then with the rest to work with. Now, we have, and this is where the rough work is helpful, we have an ax squared take away a 6x squared. Now, that is literally it. You cannot do anything. But to help with the division step next, we can kind of do a highest common factor. and pull out the x squared. Now usually we pull out the highest common factor in front, but because that a minus 6 is going to be a coefficient, the x squared will come last. So this is a minus 6 x squared, and then here I end up with a minus 9x. I bring down the final part and I go again. So my little rough work here, I want to divide a minus 6x squared by x squared, and that leaves me with just a minus 6. This is plus a minus 6. I'm going to leave it in a bracket like this just for the moment. So then we multiply. So I get a minus 6x squared plus 3 times a minus 6x minus 4 times a minus 6. So you can see how complicated this is getting. So this is probably a method that most students will go, oh, I can do long division. But it's always going to be challenging when there is unknown coefficients. So just be very, very careful when you're working with it. So what we have now is, and I'm going to write this out, minus 9x minus 3 times a minus 6x, we can clean it up in a second, plus b plus 4 times a minus 6. Now what we have here is the remainder. And because we know that x minus 1 and x plus 4, because we know both of them were factors, and then that x squared plus 3x minus 4 was a factor, we know that the remainder should equal 0. So we're going to let this equal 0 and then solve. So letting the remainder equal 0 gives me this. Now you'll notice how we have x's, a's, and b's. So what we actually have here is an identity. So we're going to split this up into x terms and non-x terms. That's the only way we're going to be able to solve it. Non-x terms. Now, just that 0 sometimes throws people. So we have a minus 9x minus 3 a minus 6x equals, and there's no x's on the right hand side. So you can write 0 or 0 x's if you prefer. The x's, we can divide across by an x, we can ignore the x's, we can focus on the coefficients, whatever way you want to think about that. We then have minus 9 minus 3a plus 18 equals 0. Minus 3a plus 9 equals 0. Minus 3a equals minus 9, so a is equal to 3. So we get our first a there, or our first letter. So then let's use our non-x terms. So that's anything that doesn't have an x attached, which is this piece here, and that's equal to 0 because there's nothing on the right hand side. So I get b plus 4a minus 24 equals 0. We know that 3 is a, so we can put that in. So we get b plus 12 minus 24 equals 0. So b minus 12 equals 0. So b is equal to 12. So we get our value of a as 3 and b as 12. So that's our second method. Like I said, it's not the nicest, it's probably the most obvious, but it can be so tricky to work with that long division. Now, if you feel very comfortable with long division, that's brilliant. But sometimes I find the long division is tough enough on its own that when you start putting in unknown coefficients, it all tends to fall apart. So the last method I'm going to show you for this is using roots. Now, this is, in my opinion, the easiest of the methods, but it's the least obvious. So it's the one you mightn't recognize. So because we've been given a factor of x minus 1, we know that that means there is a root of x equals 1. So that's the factor theorem. So we also know if there's a factor of x plus 4, then there is a root that x equals minus 4. And we know that when I sub in a root, so when I do f of 1, it should equal 0. So I get 2 times 1 cubed plus a, 1 squared minus 17 times 1 plus b. That should all equal 0. So that gives me 2 plus A minus 17 plus B equals 0. A plus B minus 15 equals 0. A plus B equals 15. And that becomes equation 1. We then do the exact same thing with my second root, so that's minus 4. So when I do f of minus 4, because minus 4 is a root, we should get that equal to 0. So that is 2 times minus 4 cubed plus a times minus 4 squared minus 17 times minus 4 plus b should equal 0. 2 times minus 4 cubed, 68, so minus 128. Minus 4 squared is 16, so plus 16a. Minus 17 by minus 4 gives me a plus 68. Plus b equals 0. So 68 minus the 128, so I get 16a plus b minus 60 equals 0, or 16a plus b equals 60. And that becomes equation 2. So now we're going to do some simultaneous equations. So working with these two equations, we can find a value for a and a value for b. I'm going to eliminate the b's, so I'm going to change the signs of equation 1. The b's then eliminate, so minus b plus b is 0. I get 15a is equal to 55. Apologies, that's 15, not a 5, so that's 45. So then dividing both sides by 15, I get a is equal to 3. So I go back to either equation. I'm going to use equation 1. So that is a plus b equals 15. We've just found a is 3, so 3 plus b is equal to 15. So taking a 3 from both sides gives me b is 12. So this, I think, is the most straightforward of the methods, as long as you can spot it. So remember that anytime we have factors, we can also then write them as roots. And when we sub a root into a function, we know the answer should be 0. But there are 3 different options to approach this question. I would say the majority of the time you'll have a choice. We generally see questions where we're missing one factor, and in that case you can see here all my options. If you only have one factor, then long division really is your only method, but we don't see that a lot because we'd end up, I suppose we can't do as much when we just divide in one factor. But this will give you a sense of these higher level questions.